Okay, so welcome to section 5.3, which is numerical measures of center. So numerical measures of center. Okay, so let's note. So in this section, we're going to use quantitative data, meaning numbers. So in this section, we will be using, or be measuring, how about that? Measuring quantitative, as in quantity, quantitative data, that is, i.e. numerical data, numerical data. Okay, so now we're going to do measures of center, meaning how do we measure the quote, quote, center of a data set? So measures of center, there's a few different ways. The first one you probably know really well. So definition. Definition. And that is the mean or average. So the mean, that's what we're defining. The mean or average. That is a measure center. So of a data set. With n datum. So with n datum, that is data points, i.e. data points. Data points is the sum of the data. So is the sum of the data points. The data points divided by the number of data points, so divided by n, divided by n, and denoted by x bar. So that is x bar is going to be, we add the first data point to the second, to the third, all the way to the nth data point. We add them all together. Then we divide by n. Pardon me. And this will make more sense once we actually apply it. Okay, so next definition. Definition. Is going to be the median. So the median, that is a measure of center. So the median of a data set. It is what it sounds like. It's the point in the middle. So is the value exactly in the middle? Value exactly in the middle of the set. In the middle of the set. Middle of the set. When ordered from smallest to largest value. So when ordered from smallest to largest value. Okay, so let's note, pardon Pardon me. So note, if there's an even number of data points, so if there is an even number, of data points, so then we're going to have the average. So then we average, meaning we add up and divide by 2. So we average the 2 middle points, or middle values rather, to find the median. And this will make, once again, more sense once we actually apply it. Median. And final definition in this, before we do an example, is a definition. And that's the last definition for a measure of center, and that would be the mode. So the mode, M-O-D-E, the mode of a data set is the most frequent value. So it's the most frequent value. The most frequent value. That is the value that's repeated the most. Okay, so let's see this with an example now. So for example, let's find the mean, median, and mode. So find the mean or average, median, the middle point, and mode, the most frequent value, and mode with respect to, with respect to the number of animals, the number of animals per category of 5 cats, 2 dogs, 13 fish, 1 ferret, and 13 rabbits. Okay. My legs are hurting me trying to sit here this whole time. Okay. So let's first find the mean. So the mean, remember, is x bar, or the average. The mean x bar, what I do is I take the sum of the data set, divide by the number of things. So 1, 2, 3, 4, that should be sufficient. So what do I have? Let's color code. I have 5 cats. 5 cats. I have 2 dogs. I have 13 fish. I have, let's do that in dark purple, 1 ferret. 1 ferret. And then I have 13 rabbits. So I have 1, 2, 3, 4, 5 different categories. So I divide by the number of categories. So what do I have on top? 5 plus 2 is 7, and 13 is 20. 13 is 33, and 1 is 34, divided by 5. Well, if it were 35, it'd be 7, but I have 4 over 5, which is the same as 0.8, so that's 6.8. You can use your calculator. Okay, now let's calculate the median. So the median is going to be the number that's right in the middle of the data set. So in order, the smallest value was 1, right? So I had 1. And you know what? Let me change the color of this since I've already used it. Let's change this to, what color haven't I used? Green, I guess. Okay. So we'll use green for the median. So 1, 2, 3, 4. So I have 1 as my smallest number. I have 2 as my next smallest number. I have 5 as my next smallest number. And actually I can move this over. Then I have 13 as the next smallest number. And 13 as the next smallest number. Okay, so these are my 5 data points in order. And in fact, I'm going to copy and paste this while I'm at it because I know what's coming. Okay, so now the median is a number that's right in the middle of the data set. So do you agree that 5 is right in the middle? So the median equals 5. If I order this from smallest to largest. Okay, so that was the median. Oop. Okay, so now let's do the mode. Yeah, maybe I'll use pink for the mode. So the mode is the most frequent value. So the mode, so I'm going to paste the data set again. And you agree the most frequent value, the only value that appears twice, is 13. So the mode is 13. Okay, so those are the, quote, measures of center, mean, median, and mode. Okay, so now let's do measures of variation. So that's the next subtopic. So measures of variation. Measures of variation. So how do our data vary? Oh, there's different ways in which data can vary. I don't like that N. Let me make that better. Variation. Okay, so first definition will be the range. So definition. So the range of a data set. So we're defining range. So the range of a data set is the difference, meaning subtraction. So is the difference between the largest and the smallest values. Between the largest and the smallest values. And the smallest values. Okay, so for example, in the data set below, or above rather, we had the set 1, 2, 5, 13, 13, 2, 5, 13, and 13. So this means that the range is going to be 13 minus 1, or 12. And that makes sense. So my range is from 1 to 13, which is a range of 12 data points. Okay, so another definition. Okay, the standard deviation. The standard deviation, that's what we're defining. Standard deviation. Okay, measures how far. Measures how far each data point, lies from the average or the mean lies from the mean or average. So the standard deviation. So we're basically asking how much does this data point deviate from the mean? So theorem. Standard deviation. So let's let n be the number of data points. So be the number of data points in a set. Data points in a set. And let's do x sub 1, comma x sub 2, comma dot dot dot, comma all the way to x sub n, be the data points themselves. So be the the data points themselves. Then the standard deviation S, the standard deviation S is given by, looks like the standard deviations, let's do comma S, is given by so we have S is going to be equal to, so this is going to be a bit much. So what we have in the numerator is going to be the first data point minus the average x bar, then we're going to square that. I'm going to add to that the second data point minus the average x bar, square that. I'm going to keep on doing that till I add the final x sub nth data point, subtract the average and square that. Then I'm going to divide this whole thing by n minus 1, and I'm going to take the square root of that whole value. Okay, so it's kind of cumbersome, but let's see what it is in practice, that standard deviation. So for example, so let's find the standard deviation. So find the standard deviation. Standard deviation. For the 5 points. Let's do 2, 3, 6, 7, and 12. Okay. So there's 5 points. So I know that n is 5, which means that n minus 1 is 4. Okay, let's find x bar. I'll do that, I guess, in purple. So x bar, the average, I'm going to sum the 5 points and divide by 5. So 1, 2, 3, 4. So let's color code. Let's have 2 be yellow. Let's have 3 be orange. Let's have 6 be hot pink. Let's have 7 be dark purple. And let's have 12 be... What color should I use? I've already used blue. Oh, 7 was dark purple, but didn't that other line? And let's have 12 be blue. Okay, so what do we get here? We have 2 plus 3 is 5, and 6 is 11, and 7 is 18. 12 is 30, divided by 5, which is 6. So my average, x bar, or mean, is 6. Okay, so now I'm going to do all of these x minus x bars. So if I do first coordinate x sub 1 minus the average and square that, so minus x bar, and square that. What I get then, the first data point was 2. So 2 minus the average, 6. I'm going to square that. So that's going to be a negative 4 squared, which is a negative times a negative, so that's positive 16. The next data point, x sub 2 minus the average squared, will be 3 minus the average quantity squared. And the average, of course, was 6, so x bar is 6. Okay, so 3 minus 6 is negative 3 quantity squared. Once again, a negative times a negative is a positive, so I get positive 9. The third data point, x sub 3 minus the average squared, is going to be 6 minus the average squared, where the average, of course, x bar, was 6. So 6 minus 6 is 0. Thank goodness, that's an easy number. 0 squared is just 0. The next number we had was the fourth data point, which was 7. So this becomes 7 minus the average, which we're going to square. And the average x bar, of course, was 6. So 7 minus 6 is 1 squared. 1 times 1 is 1. Last but not least, we had the fifth data point, minus the average quantity squared, be 12 minus the average quantity squared. X bar is 6. 12 minus 6 is 6 squared is 36. Okay, so now I can finally start to analyze what S is. Holy free holy. Okay. So what do we have here? S is going to be a big square root of the sum of all of that stuff. So we have S is going to be the square root of, okay, so the first number was 16. Actually, I'm going to do 1, 2, 3, 4, all over. Okay, we had 16 for the first guy we just analyzed. Then we got 9 as our value for the next, 0 for the next value, 1, and finally 36. And I'm dividing that by n minus 1, which we found to be 4. Okay. So all of that underneath the square root. Okay, why is that not working for me? Okay, let me try and draw the square root a bit better. Okay, so we have S is going to be the square root of, let's see, 16 plus 9 is 25, plus 1 is 26. 26 and 36, well, 20 and 30 is 50, 6 and 6 is 12. So I claim that that's going to be 62. And we're dividing that by 4. So 4 goes into 60 15 times, and 2 over 4 is 1/2. So I claim that S is going to be the square root of, square root of 15.5 or 15.5. And actually, that's approximately, when you put that in your calculator, 3.94. So what does that mean? So, what color should I use? Purple. That is, i.e., the majority of the data set values lie within 3.94 points of the average, or the mean x bar equals to 6. Okay, well, let's look at these data points. 2, 3, 6, 7, and 12. So 3.94 is about 4 if I round up. So if I go down 4 from 6, I get to 2. If I go up 4 from 6, I get to about 10. So the majority of the data points are within about 4 units of 6, which is the average. So that's what that means, the standard deviation. Okay, so continuing on. So definition. Definition. Okay, so data can be split into 4 parts. So data can be split into 4 parts. 4 parts. And remember, a dollar has 4 quarters. So these 4 parts are termed quartiles. So termed quartiles for quarters. Quartiles. And they are annotated by capital Q1 for quartile 1, capital Q2 for quartile 2, capital Q3 for quartile 3, and of course capital Q4 for quartile 4. Okay, so let's note so quartile 1 is the value for which 25% of the data lie beneath it, or lie beneath. Let's do quartile 2, maybe in blue. So quartile 2 is the value for which 50% of the data lie beneath, which of course is the median. So 50% of the data lie beneath, i.e. the median. The median, it's the middle point, hence 50%. Okay, quartile 3 is the value for which 75%, so is the value for which 75% of the data lie beneath. And it should be evident that quartile 4 is the value for which 100% of the data lie beneath, and that is known as the maximum. The data lie beneath. The max. Okay, so definition. Again, definition. We're almost there. So the 5-number summary of data. So the 5-number summary. That's what we're defining. The 5-number summary. 5-number summary of data are as follows. Okay, so the minimum value. Then quartile 1. So may need to average. Average 2 values. 2 values. But you'll see this in the next example. Then, of course, quartile 2. 2, not 1. Quartile 2, the median. And quartile 3, and once again, you may need to average. To average 2 values. And last but not least would be quartile 4, which of course is the maximum. Maximum value. Maximum value. So notice that the 5-number summary is 4 quartiles plus the minimum. Okay, so let's do an example. So for example, let's find the 5-number summary. So find the 5-number summary. 5-number summary for the data set. Let's do 2, 5, 5, 7, 8, 9, 11, 11, 13, 19, 21, 21. Okay, so this is in order. So let me go ahead and put this. I'll just do the data in blue, shall we? Should I do it in blue? Yeah, okay, I'll do it in blue. Okay, so we have 2, 5, 5. We have 7. Oh, these are too close together. I think I can space this out a bit better. Let me see. 2, 5, 5. 7, 8, 9, might need 11, 11, 13, 19, 21, 21. Okay, I ran out of room, didn't I? Let's see. Maybe I can move these guys a bit to the left here. Give myself a little bit more room. So notice that we can break this up. It breaks up nicely into 4 parts because there are exactly 12 data points here. Okay, so let's look at first the minimum. So minimum. And that, of course, is 2. So that's what we're adding to the quartiles to get our 5-number summary. But now we need quartile 1, the value for which 25% of the data lie beneath. So quartile 1, get this. Well, it's in between 5 and 7. So what's the number that's in between 5 and 7? Well, that's going to be 6. Okay, so quartile, what color should I use? I guess I can use blue. So quartile 2 is the median, right? So quartile 2, But that is the number that's exactly between 9 and 11. So 9, 10, 11. So quartile 2 shall be 10, or the average of these two. Actually, let me put this down a bit. So the number that's exactly in between those two. And you know what? I think I'm going to do that in purple because it's too much blue. Okay, so now the next number, let's do pink. So this would be quartile 3. And that's the number that's in between 13 and 19. So the number that's right in between those two is 16. I'll show you how I got that in a minute. And last but not least, the fifth and final number in the 5-number summary will be the maximum. Maximum. And that, of course, is 21. Okay, so let me rewrite this down here. So we have our first in the 5-number summary is minimum, which we see is 2. Then we have quartile 1. Quartile 1 is just the average of the two numbers divided by 2. The two numbers are 5 and 7. So 5 plus 7. So 5 plus 7 is 12. Divided by 2 is 6. So check mark, we got that right. Then the next number is the median, which is the number right in the middle, or quartile 2. And once again, we had to average two numbers. And those two numbers were 9. 9 and 11. So 9 plus 11 is 20. Divided by 2 is 10. Okay, then we go to quartile 3. Once again, we had to average two numbers. So add them up, divide by 2. And those two numbers were 13 and 19. So 13 plus 19, that's 32. So 32 divided by 2 is 16. And finally, the last number was our maximum. So that's a fifth of the 5-number summary. So maximum, and that was 21. So there we are, the 5-number summary. Okay, now we have one more item before we go, and that would be a definition. Definition, okay. Okay, so a box and whisker. A box and whisker plot. Whisker plot, that's what we're defining. Box and whisker plot. Or chart. I should put chart. That's more formal. So a box and whisker chart represents the 5-number summary with horizontal axis only. And this will make more sense once we actually do it with horizontal axis only. And we have the following. A rectangular box. So a rectangular box. Hence the term box and whisker. This is the box part. So a rectangular box. From quartile 1 to quartile 2. Sorry, to quartile 3 rather. Okay, then second will be a vertical line. And vertical line in the box at quartile 2. And then whiskers on either side. So whiskers on either side to the min and max. To min and max. Okay, so let's do this. So for example, so let's create a box and whisker chart. So create a box and whisker chart. Whisker chart for the following data set. Following data set. Actually, I don't like the word following there. It's way too large. Can make this better. Or let me just put for the data set, period. For the data set. Let's do the same one. That was 2, 5, 5, 7, 8, 9. 11, 11, 13, 19, 21, 21. Okay, so let's recall. So this is the same set from above. So we had a minimum of 2. Minimum equal to 2. We had quartile 1 at 6. We had the median at 10. That's a median. We had quartile 3, which was in what color? Quartile 3 was in pink. Okay, so quartile 3 in pink at 16. And then we had a maximum value at 21. Okay, so what I'm going to do is I'm going to put a horizontal axis, just a horizontal line. So something like so. And let's say that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay. Okay, so what I'm going to do is I'm going to put my minimum value is 2, so I'm just going to put a little line here at 2. Quartile 1 is at 6. I'm going to put a bigger line here at 6. Quartile 2 is at 10, so I'll put the same 3 blocks there. Quartile 3 is at 16, so here we are, 16. And then the maximum is at 21. So let's see, 21 will be about here. Okay, does that look okay? Okay, so what I'm going to do is I'm going to create a box between quartiles 1 and 3. And then whiskers from the box to the min and max. And there we are. This is a box and whisker chart. Oops. If I can make that a bit better. Okay, so this would be, here's the min. We have quartile 1. We have quartile 2. We have quartile 3. And so I want you to note something though. What measure of center do we not have here? So let's note. What color didn't I use? Blue. So let's calculate x bar. X bar would be adding all of these numbers up. So what numbers do we have? We have the numbers 2, 5, 5, 7, 8, 9, 11, 11, 13, 19, 21, and 21. We're adding up all of these numbers. And then we're going to divide by the number of numbers, which was 12. Okay, so what do we have here? We have that x bar is equal to, well, let's see. Let's see, 2, 5, and 5 is 12. Okay, so I'm going to take this and say 12 plus 7, 8, and 9. 3 times 8 is 24, so that's 24, which is a multiple of 12, plus, let's see, I know that 11 and 13 is 24, so do those, plus, now let's see, 19 and 11, so that's what, 30? Is that going to get me anywhere? Nope, but 30 and 42 is 72. Okay, so that does get me somewhere. 72 divided by 12, so I get that x bar is equal to, well, 12 goes into 12 once. 12 goes into 24 2 times. And 12 goes into 72 6 times. Okay, so I claim that x bar is 5 and 6 is 11. Okay, so note that 11 is not on the box and whisker plot. So note the mean x bar, or average, is not on the box and whisker plot. Box and whisker chart. Whisker chart plot. Tomato, tomato. Okay, so I hope that is making sense. I'll see you in the next video.